So that opens the door to a lot more problems that we could do. So what's the derivative? How does the derivative change when we replace x with an expression in x? Well, we pull out the chain rule. So we'll get 1 over u, but then we'll have to find the derivative of u. And I write that with these symbols, y prime. If y equals ln of u, then y prime is ln of u du dx. So let's talk about a couple of those in action. Just a couple. You'll get plenty of practice. So let's look at y equals ln of 2x. That's our u. It is an expression in x. So the derivative of, what am I saying here? Boo-boo. Poo-poo. All right, the derivative is 1 over u du dx. Sorry about that. All right, to use this rule, I'm going to take the derivative by putting 1 over 2x, that reciprocal, followed by the derivative of that expression. In this case, the 2's cancel, and I get 1 over x. All right, let's try another one. Let's say y equals the quantity ln of x cubed. So this is something cubed. So we have 3 something squared, but it's followed by the derivative of that something, chain rule. So what's the derivative of ln of x? We just learned it, 1 over x. So there's lots of ways, lots of examples I could show you, but I think you'll get the gist of it just from those two. All right. So now I am wondering about e to the x. I'm wondering about its graph first of all. We've just covered y equals ln of x. And if you look at the line y equals x cutting right through the third and first quadrants, we can find y equals e to the x by looking at its reflection across that line. So these are inverse functions of one another. So imagine this is wet paint, and this is the line. I'm going to fold this paper along. What will show up on the other side from the imprint? So it turns out it'll go like this. It goes zinging up. And you've actually had this before in your math. All right, so that point is 1, 0. And this is the graph y equals e to the x. Now we're going to talk about the derivatives for that one. Let's see if you have any guesses. Look at the slope there when x equals 0. Here's the slope at x equals, say, minus 1, x equals minus 2, x equals 1, x equals 2, x equals 3. It's going to be kind of hard to visualize it this way, so I'm going to just use math. Then we'll come back up here and see if these slopes make sense. All right, first of all, let's talk about the ln of e to the x. So remember, the base is e, and this is saying what exponent do I give e to get e to the x? X. All right. Now I'm going to take the derivative of both sides. I can write that with a notation where I say d times this side, not times, but d, derivative of this expression, is d, that expression, dx. So that just means the derivative of this expression equals the derivative of that expression. So I'll just use the same notation. So what is the derivative of the ln of u? We just learned it's going to be 1 over u times du dx. So here's the 1 over u part, our u being e to the x, 1 over e to the x times the derivative of that using the chain rule. And that's what we're trying to find, actually. I'm trying to lead you to the derivative of e to the x. What's the derivative of 1? I'm sorry, gave that away. What's the derivative of x? 1. All right, so if 1 over e to the x has to be multiplied by some quantity here, and it has to give us 1, what must this be? It must be 1 over e to the x times e to the x over 1, or e to the x. That's the only thing it could be for it to equal 1. So therefore, the derivative of e to the x must be e to the x. So if y equals e to the x, y prime is also e to the x. What? All right. I always say there is a God when I see that, because here's what that says. Here is the value, say x is minus 3. So we go up here and we read the value of that function right here. I don't know what it is, but e to the minus 3, which is 1 over e to the 3, whatever that is. But like 1/27. This slope is very, very flat. It looks almost flat, but it has some slope to it. So it could be something very tiny, like the value of y is. So then here it gets more slope, and this value is, say, x equals -2. Then we would have the value of it over on the y-axis would be e to the minus 2, which is 1 over e squared. If e is 3, it's about 3 times 3, about 1/9. So this has a little bit more slope than this. And then here, right here, when it crosses the x-axis at 1, we see that the slope looks like it is about 1. And as we go, it sort of makes sense. It is everywhere the graph's value is equal to the slope, which is very odd to think that there could be such a thing, that there is a function out there, y equals e to the x, where the value of it, when I put in, say, 4 for x, I get e to the 4th. It is the same value for the slope at that point. To think that a function out there exists that has the same value as it has for its slope at every point is quite miraculous. There has to be a God to have such a thing exist in the world. There's just too much order. I cannot bear it. All right. So only us mathematicians can see the wonder of it all. So e to the x is very special. It's its own derivative. So the more helpful expression is e to the u. Y prime is going to be e to the u followed by the chain rule, the derivative of that u, where u is an expression in x. So let's do one of those. Y equals e to the 2x minus 1. And the derivative is going to be the same, e to the 2x minus 1, followed by the derivative of that, and that is 2. All right, so those are the two main points that we came up with. If y equals ln of x, y prime, we'll say u, so we can be a lot more general, and y prime equals 1 over u du dx. And if y equals e to the u, y prime is e to the u du dx. All right, big deal. Hot stuff. All right, so put that in your pipe and smoke it tonight, and be ready to use it tomorrow in class. Till then, good night.